Hi everyone, welcome to my channel. Today we will be discussing with the remaining types of point defects. In our previous video, we were discussing about the imperfection in solids and different types of defects and different types of point defects. So now let's continue with the impurity defects and non-stoichiometric defects. If you have not watched that previous video, please make sure to watch that video. You can find the video link in description below. So now let's go with impurity defect. What is impurity defect? It is a defect where foreign atoms will replace the atoms which is a solid made up of, means by which the solid is made up of. Those atoms will be replaced by the foreign atoms, and the process of adding impurity to the crystalline is known as doping. And now let's take the example of NaCl and strontium chloride. Here, if this is a crystal of a NaCl, strontium, when an impurity is added, for example, we'll be taking here a strontium. Strontium will replace two sides of the sodium and occupy only one side, so the another side will be remaining empty. So we can say that number of strontium occupied is equal to the number of empty space. So this was about the impurity defect. And the next one is non-stoichiometric defect. We can find two types of defects in this, that is metal excess defect and metal deficiency defect. So now let's know what is this metal excess defect. What is metal excess defect? Why does it cause? Means it is caused due to the anionic vacancy. And you can find such defects mostly in the alkyl halides like NaCl, KCl and etc. So now let's take the example of NaCl. In a NaCl crystal, when it is heated at temperature where the sodium gets evaporated, what happens is the sodium atoms which will be present will get deposited on the surface, and at the same time chlorine Cl- ions, they also diffuse to the surface of crystal, and they both combine to form NaCl. We know because sodium loses one electron. When sodium loses one electron, only then it can combine with chlorine. So electrons will be lost, right? These electrons diffuses into the crystal and occupy the anionic sites will be occupied by these electrons released by the sodium to form Na+. So as a result, crystal will have excess of sodium and the anionic sites occupied by unpaired electrons. These electrons will occupy the space, right? That is anionic sites. Those will be called as F centers. These will be called as F centers. And this was about the metal excess defect. And next one is metal deficiency defect. In this metal deficiency defect, what happens is the solids for preparation of the solids, it is difficult to prepare in their stoichiometric compositions. So there will be the less amount of metals. So there is a deficiency in the metals. That's why it is named as metal deficiency defect. The less amount of metal will be compared to stoichiometric proportion. So we can take an example of ferrous oxide. It will be found in the composition of Fe 0.95, but it actually ranges from, the range may be from 0.93 to 0.96. Okay, in the crystal of ferrous oxide, some Fe2 plus, that is ferrous ion, which is cation, are missing and lose the positive charge, and this made up only the presence of the required Fe3 plus. This is the ferric ions. So this was about the metal deficiency defect. So guys, if you have liked this video, please don't forget to click on like button, and for more videos please subscribe to my channel. Thank you.